So we started with linear equations in chapter 6. And the first form of the linear equation that we did was standard form, which is ax plus by equals c. This is asking for the x and the y-intercepts. Remember, to find the x-intercept, you plug in a 0 for the y, which means it's always going to be that c value divided by that number in front of x. In this case, the c value is 4. The number in front of x is 1, so my x-intercept is 4. And we would put that on the x-axis at the number 4. The y-intercept then is what happens when you plug in a 0 for x. So this always ends up being that c value divided by the b, or the number in front of y. And so in this case, this would be 4 divided by -1, which gives you -4. And we would plot that on the y-axis. The final step here would be to connect those points with a line, and then put the arrows at the end to indicate that it continues. And so you've answered the question, x and y intercepts, sketching the graph of the line. The next part of this chapter dealt with some formulas that you needed to know. So the first one that they're asking for is the slope of the line. If you remember, the slope of the line is found by subtracting your y's, putting that in your numerator, subtracting your x's in the denominator. And so if you just label your first group and label your second group, then you can just plug those in. So we're going to say y2 minus y1. Make sure you watch those positives and negatives. And then x2 minus x1. If you recall, subtracting a negative is the same thing as adding. So we're subtracting, adding the opposite. And so for this one, we would have a -12 plus 18 on top, which would give you a 6, and a 9 plus 4 on bottom, which would give you a 13. So your slope here is 6 over 13. From there, we moved into the slope-intercept form of a line. The slope-intercept form of a line is y equals mx plus b, with our m being the slope and our b the y-intercept. And so in cases where they give you the slope and they give you the y-intercept, you literally just write that equation, y equals mx plus b. And remember, when you're adding a negative, you can just write that as subtraction. So -1/5 x minus 1. We're going to continue using that slope-intercept form in the next couple of questions. So we're going to continue to use that y equals mx plus b. But in this case, they didn't give us they didn't give us our y-intercept. They only gave us our m. So we're going to use the x and the y to figure out what our b is. You can plug in the y equals m times your x plus b. And so now we're just going to use our basic algebra solving. We have -3/2 times -2. Those will cancel. Negative times a negative is a positive. Subtract that 3 over. Your b value here is 0. And so when I plug that in, I would have y equals mx plus b. And of course, if I'm adding 0, I can just leave it as -3/2 x. So this final question using slope-intercept is actually putting it all together. They've given us 2 points, so we do not have the slope and we do not have the y-intercept. So we're going to use these 2 points with that slope formula that we just used a little while ago. We are going to say y2 minus y1 over x2 minus x1. So that's the first one we're going to use, and that is just to find our slope. And so when we subtract those, we get 3 minus 1 is 2. 3 minus a negative 4 is 1. So our slope value here is just 2. And then we're going to use either of these points in our y equals mx plus b. So we're going to say y equals mx plus b. We're going to plug in our y. We're going to plug in the m that we just found. We're going to plug in our x plus b. I don't have to use both, just one of them. And then I'm going to solve for whatever my b is. So when I add that 8 over, I get that b equals 9. Now I have my m, I have my b. I'm ready to write that slope-intercept form. Y equals mx plus b. So we then did some graphing using our slope-intercept in our standard form. When it is in slope-intercept, we started our y-intercept, which is that addition or subtraction there, so positive 1 on my y-axis, and we move according to our slope. So 3 over 2 means up 3 and right 2, or remember we can do a negative over a negative, which means down 3 and left 2. So if I go up 3 and over 2, I can put my second point, and I can graph. We also graphed inequalities, and so with inequalities, you can put it in slope-intercept form. We want to subtract that 9x over, and then we want to divide by the number in front of y. Remember, just review, when we divide by a negative for inequalities, it flips that sign. And then we're going to graph the same way. 4, I'm going to go down and left because I would go off my graph. This will be a dashed line, and I will shade below. Solve by graphing literally means graph two lines. Okay, so this is identical to what we just did. We are going to start at our y-intercept. You should have started at -8 here. This slope right here is -1, which means you could have a -1 over +1 or a +1 over -1. So I can go up and left, or I can go down and right. Either one is going to give me the same exact line. And then I'm going to connect those to graph that first one. My second one starts where? Well, I start at -3. Now I have a -1/6 slope. So I'm going to start at -3, down 1 over 6, or I can go up 1 and right 6. Either one is going to give me the same thing, and I think I actually just didn't graph this well, but that's okay. You can walk it up if you want to. So like if I kept walking, you would see that my line was getting a little bit off, and that's actually where they cross. So your answer is where these two lines cross. All right, so when I say you can walk it, I could keep walking up this line right here, and I could see that it's actually going to cross at that point. That is my answer. Where they cross is my answer. And so my answer here is going to be my x value, -6, my y value, -2. All right, solve by graphing. That's what you should have gotten there. The next ways of solving were elimination and substitution. With substitution, I have to have one of the variables completely by itself. I'm going to choose to get that one completely by itself, which means I'm going to move that over. So this one looks like x equals -4y plus 7. Remember we said in substitution, you take that entire group and substitute in for the variable that it equals, which is x. So you should have substituted that in and said 2. Instead of x, we write negative 4y plus 7. Then we write minus 4y equals 2. We just substituted that piece. Now I'm distributing. Negative 8y plus 14 minus 4y equals 2. You should have combined your like terms. Negative 12y plus 14 equals 2. Subtract your 14. Your y value here should have been 1. But I'm not done. I need an x value. You should have taken that 1 and plugged it in here. So I have x equals negative 4 times 1 plus 7. Negative 4 plus 7, x equals 3. So my answer is going to be an xy just like it was when I was graphing. I have 3, 1 as my answer. That was substitution. The next way that we did was elimination. Elimination is eliminating one of my variables. Which variable do you think I would want to eliminate here? Value here. However, I can't just start adding because they would make a negative 2, not a 0. And so I have to multiply everything on that second row by a negative, which means that 2 becomes negative, that y becomes positive, that 8 becomes positive. Now I'm ready to add down. Remember, this is also called solving by addition. Negative 6 and negative 2 gives me negative 8x's. 8 and 8 gives me 16. So my x value here, you hopefully got a negative 2. However, like all of these problems, I need 2 variables to finish it out. So I can choose either of these equations to plug in that negative 2. Negative 6 times negative 2 minus y equals 8. 12 minus y equals 8. Subtract that 12 over. 8 minus 12 gives me a negative 4, but I'm not quite done because I still have a negative 1 in front of my y. I have to divide that out, giving me the answer negative 2, positive 4. That's what you should have gotten there. This is with the wind against the wind, or with the current against the current, okay? So you're going to have an x plus y and an x minus y, all right? If you see the word downstream or with, that is when you add them. Then the way back, you will subtract them. All right, back you will subtract them. So with or downstream or with the current, something like that means add. Against the current or back. If you went, whatever you did one way, way back is going to be the opposite, right? And so it says a boat traveled 176 miles each way downstream. I'm going to add there. So I have 11 hours, and I'm going to add my x and y to figure out what my rate is. The distance is the same. It is 176 because that's what they told me. The way back is 22. And I'm going to subtract here. All right. 176. All right. So what's nice about this is I can distribute, or I could go ahead and divide, but I can distribute that 11x, 11y equals 176. I can distribute that 22x minus 22y equals 176. I want to eliminate a variable. Well, the y is already an addition and subtraction. So if I multiply this whole guy by 2, this equation will be 22x plus 22y equals, and you just need to multiply that guy out. Just do your regular multiplication here. So, right, do your regular multiplication. Now, if these were smaller numbers, I would say go ahead and divide. But larger numbers, you can go ahead and distribute. It's going to cancel out. So I'm going to add these two now, right? My y's will cancel. I will get 44x. I will get this ginormous number, but don't worry, I'm going to show you. All right. That's 528. Helps to write down the right number.
That's going to be a 5 or 4.
That's a 5. So I have 44x equals 528. Before you try to start doing long division, think of it as a fraction, all right? What goes into 528 and 44? An easy number. Yeah. So start with something easy. Divide both of these by 2, right? So 5 divided by 2 is 2 with 1 left over. 12 divided by 2. 8 divided by 2. Then we have 22 on bottom. What do you think goes into both of those? 2 goes into it again, right? So I have 132 divided by 11. That's actually perfectly divisible. That's one of your multiplication tables when you memorized 1 through 12. 11 times 12, yeah, so that's going to be 12. That's going to be 12, right? Just so you know, you could have divided at the very beginning. It would have worked. So I think what I give you is I give you smaller numbers on your test, but you can actually do this up front, but some people may not see that that evenly divides. So if you don't see that it evenly divides, it may be a little more difficult. You can go ahead and do it up front, yeah. So plug it in, you're going to find your other answer there is 4. So 12 and 4 are going to be your two answers, but typically, and just because they were bigger numbers and you may not have seen it, you can divide at the beginning and you'll get smaller numbers. They're always going to be divisible. I'm always going to give you a number here that is divisible by that, by the way. So you can divide it out up front. All right, how do you graph these? Well, you graph them just like we did our inequalities, right? Start at +1, go down 1 and over 2. It is just less than, so that is a dashed line. Dashed line. And then it is less than, so that means shade below. All right, the second one starts at +8 and goes down 9. So we're going to go all the way down 9 and over 4. That is also a dashed line, but we are going to graph above it. And so this is below. It's above this guy right here, which means this little tiny wedge is going to be our answer. All right, so I'm going to write down the properties of exponents. You probably want to make note of these. When we multiply like bases, so we multiply the same base, we are going to add those exponents. When we divide like bases, we subtract the exponents. When we take a power to a power, we multiply those exponents. When we have a group to a power, we take everything in the group to that power. Couple of extras, anything to the 0 power is just the number 1. Anything to a negative power gives me a fraction or puts it in the denominator. Yep, so I'm going to say x to the 7th, and then I have y to the -1. What you need to notice is these instructions say positive exponents only. So my 16 and my x to the 7th don't change at all. I'm done with those. But I have y to the negative 1, which drops him to the bottom of that answer. So my answer here is 16x to the 7th over y. For the next one, what I typically do is I will just go ahead and draw my line. For numbers on top, I guess I have a 1 there, right? Since I don't see anything, it's always a 1. 1 over 3 I can't reduce, right? If I gave you 1/3 and said reduce it, you would be like, I'm done. So for your numbers, 1 over 3 just stays where they are. Then I'm going to look at each variable individually. I have my x's. When I am dividing, I subtract those x's, right? The exponent's there, so I have -2 minus 3. What is -2 minus 3? -5, which tells me where does that x go, top or bottom? Goes on the bottom to the 5th power. Then I have my y's. I'm going to do the same thing there. Y to the -2 minus a -3. -2 minus a -3 is plus a +3. So that's y to what power? Y to the 1st power. That's positive. Where's my y going to go? On the top. All right? You don't have to list that 1 if you don't want to. So your final answer here would look like this. Y over 3 x to the 5th. You are done. And then this last one is a group. So I'm going to take everything inside the group to that power. I have a 3. I'm going to say 3 to the 4th power. I have an x to the 0. I'm going to say x to the 0 to the 4th power. And I have a y to the -3. Y to the -3 to the 4th power. 3 to the 4th power is 3 times 3 times 3 times 3, which is 81. Times x to the 0 to the 4th. Well, I multiply those, so it is x to the 0. Y to the -3rd to the 4th. I multiply those. That is y to the -12th. All right? We're going to simplify this. We have 81 times, what is anything to the 0 power? It is 1 times y to the -12th. So I know I have an 81, and I have y to the negative. Where does that put him? In the bottom. So over y to the 12th. And that is my final answer here. All right, if I want you to write it in scientific notation, the number needs to be between 1, so 1 or higher, and less than 10. All right, so it can't be 10. It has to be 9.99, whatever, lower. All right, and so the first thing I decide is where does the decimal need to go to make that happen? Well, it needs to go in between the 4 and the 3. So I'm going to have 4.3 times 10 to some power, and that will be determined by how many times I moved it. I moved it 2 times, and this number was bigger than 10 when I started, which means this is going to be a +2. Had that been something really tiny, like 0.00043, I would still do the same thing, right? It's going to be 4.3, but because that started out as a little tiny number, then my movement count would be negative. All right. All right, so this one, 7.5 times 10 to the 2nd power, I'm going to move it twice, but I want it larger because it's a positive exponent, which means this number should be bigger when I'm done with it. So I'm going to move that 7.5 this direction to make that a bigger number. Remember, a positive exponent means you're going to have a large number overall, and a negative exponent means you're going to have a small number overall. All right, so this is asking you for a couple of things. Standard form here. Well, standard form means highest degree to lowest. So I look through here and I say my highest exponent is the 4m to the 6th, and then I'm just going to go down from there. Minus 10m to the 4th, minus 6m squared, and then my minus 10. That is standard form. Once it's in standard form, my leading coefficient is just that first number, 4. Name the polynomial by number of terms and give the degree. It's a 4-term polynomial. Remember, we have monomial, 1, binomial, 2, trinomial, 3. After that, you just tell me the number of terms. And the degree is this highest exponent that I listed. So I'm going to look again to that first group and give me the exponent for the degree. The degree here is 6. Remember, to add them, they must have like terms, which means they have to have the same exponent, same variable. Both of those have to be the same. All right, so I'm just going to look through it and I'm going to say this is addition. You can either group them or you can just add across. So I have an 8 with no exponent. I am adding to it from the other side an 8. I have a negative 5v to the 4th, plus on the other side, I have a 6v to the 4th. I have a positive v squared, and I am adding an 8v squared. I want to simplify these. 8 and 8 give me 16. Negative 5v to the 4th and positive 6v to the 4th give me a positive 1v to the 4th. And a positive v squared and a positive 8v squared give me a positive 9v squared. And then just like the questions above it, I really need to put that in standard form. So I'm going to have that v to the 4th. I'm going to have the 9v squared, and then I'm going to have the 16. Remember, when you FOIL, you multiply your first terms. 7n times 7n. Remember, when you multiply variables, those exponents go up. So that is 14n squared. 7n times 3, 21. And I did not have two n's there, just the one. Negative 1 times positive 7n, negative 7n. And negative 1 times positive 3 is negative 3. All right, so then we're going to leave this alone. We're going to combine our like terms. And then this doesn't have anything to combine with, so we are done. All right. You could have special cases like the next one, but if you don't remember the special case, you can FOIL it. If you do remember the special case, remember a plus minus. It ends up being the first group, which is the 4n squared, and the last group, which is the negative 64. If you don't remember that and you FOIL it, your middle terms will just cancel. So you're good. The first thing we did was common factor. You look at all three of these. If you look at 56 and 40 and negative 24 and 8 will come out. If you look at n cubed, n squared, and n, the most we can take is just one of those. Factoring just means division. 56 divided by 8 is 7. We took one of the three n's, we have 2 left. 40 divided by 8 is 5. We took one of those n's. Negative 24 divided by 8 is negative 3. We took both of those n's. That is my answer. That is just common factor. Then we did basic factoring. Remember, if you just have a number at the end, you do those numbers. But if we have something that has 4 terms, I am going to factor by grouping. Because this is just like what we did above. The common factor here in the first group is 6x. I have an x minus a 2. In grouping, if you don't see anything, you use that 1. And I have x minus 2. Then I am going to take that common group. That is one of my groups. What's left over is my other group. That's how we factored by grouping. Most of y'all are fine with the basic factoring, like x squared plus 7x plus 12. Most of y'all are doing great with that. Factors of 12 that add up to 7, right? So most of y'all do fine with that. It's when we get into the larger factoring, like the grouping and like the next one, all right? So the next one would be one where you multiply across. But again, if you see 4 and 84 and you think you have to multiply across, we should probably look for a common factor first, right? And so my common factor between all 3 of these is going to be 2. I am going to take that out first. Divide that 2 out of everything. Okay. And then I'm ready to do that multiplication across. This is the more difficult of the factoring, which is why I'm showing you this one. 2 and 4 give me 84. Factors of 84 that add up to 19. 7 and 12. All right? When you find those, you're not done. You are trying to make it look like the one right above it here. So I am going to use those, and I'm going to rewrite this whole thing using those 2 factors. Then I am going to do exactly what I did here. I'm going to factor by grouping, okay? So I'm going to group the first 2. I'm going to group the second 2. Which means I'm going to leave that 2 right here on the outside. Leave that there. I have a v in common here, so I'm going to take the v out. I have a 6 in common here, so I'm going to take the 6 out. And I should have done a minus there, by the way. So 2v. This was a minus, by the way, which means I changed that. Minus 7. This is one of my groups. This is the other, but I still have a 2 there. So make sure that you pay attention that 2, I don't know why I keep putting a plus. I keep writing a plus. I do not want him to be a minus for some reason. Make sure you leave that when you are factoring and stopping, leave the 2 out there. We're about to solve by factoring. You don't have to leave them out there when you solve by factoring, but you do when you are just factoring. Radicals. What's my method for simplifying radicals? I use what? My factor tree, right? So I have the 50. I need things that pair up. So I'm going to start with a 2. When I look at this, what pairs up? Well, that's my 5. 5 is going to go on the outside. What did not have a pair? That 2. That's going to go on the inside. When I look at my variables, we can do the same thing. I have an x. That's the only option. There is no pair for the x. The x is going to stay on the inside. For my y's, I have y cubed. Well, that's 1, 2, 3 y's, which means I have one pair that comes out. I have one y that stays in. So my final answer is 5y, square root of 2xy. Factor tree. All right, so this next one, I will not give you one like that, but that's okay. We have multiplication, which means you're multiplying your numbers. Trust me, you don't want to multiply that before you start. And you're multiplying your variables, p squared and p squared. We have 4 of those. So here we have a 5 and a 13, and this is why I would never give you this one. The factoring of that is 13 and 11, some pretty large primes. I'm not going to make you factor something that big, so do not get hung up on the 13 and the 11. Trust me. What you want to do is you want to factor each one of those numbers individually, okay? And then because you're multiplying, you can pair whatever you want to in there. In this case, I can pair up the 13s, right? And the 5 and the 11 stay in. So what number do I have on the inside? 5 times 11, I have 55. And then I can do the variables exactly like I did above. I have 4 of those, right? So how many are going to come out? Well, I have one pair here and one pair here. So what am I going to put on the outside? P to what power? P squared. So don't get hung up on the large numbers. Obviously, I'm not going to give you 13 times 11, right? But what I do want you to pay attention to is when they're being multiplied, all of those can go together, and you can use whatever you want. From there, we did distribution, which is also just multiplication, all right? So when I am distributing, remember, I multiply outside to outside, inside to inside. So square root of 10 times square root of 5 is square root of 50. Square root of 10 times square root of 6 is square root of 60. Do you think I leave it? Well, no, those both can be simplified with a factor tree. These cannot combine. When it is addition, I have to do them individually and leave them individually. So this first one becomes 5 square root of 2. And then I am going to do the other one on its own. It cannot combine with the other one. I have to leave this by itself because it was addition. The 2 can come out. The 3 and the 5 stay in. And so with addition, you can't group them all together like we did with multiplication. All right? We cannot group them all together. We also did division, like number 28. Remember with division, you want to simplify your numbers if you can, simplify your variables if you can, and then simplify your radicals, right? And so I'm going to first look at the 7 and the 2. Can those reduce? No, so they stay 7 and 2. What about my x's? Well, yes, I can take out 1x each. This has 1x to give me. This has 1x to give me. So I'm left with just 1x on the bottom. What about the y's? Yes, 3 y's can come out of each one of them. So I take all 3 from the bottom, and I take 3 of them from the top, which means I have just 1 y. Those cannot simplify any more individually, all right? I can't do anything else individually. However, if you will recall, I don't want to leave radicals in the denominator, right? And so I'm going to use that rationalizing technique. I'm going to multiply the top and the bottom by that radical. So my final answer here on the top, I have 7 times 2 inside there, which is 14. And I have x times y. On the bottom, what happens when I multiply a radical by itself? Yeah, I just get rid of the actual radical sign. Everything else stays. So I just have the 2 and the x on the bottom. Somebody tell me if I can reduce that 14 and 2 and that x and x. I cannot reduce the 14 and the 2 or the x and the x because the top is inside the radical and the bottom is outside the radical. All right? So I'm done. That is my answer here for this problem. The last thing we did in this chapter is addition, or in this part of the chapter. This is just like with variables. They have to be alike or I cannot add them. These are alike, so I just add the outsides. 3 times plus 2 plus 3 is 8, and my radical does not change. Pythagorean theorem is a squared plus b squared equals c squared. A and b don't really matter, but c does. C is always the side opposite your right angle. All right, so this is c. So when I solve for this, I'm going to say x squared plus 12 squared equals 15 squared. When I am missing a side, I will end up subtracting, because I will have x squared plus 144 plus 2 equals 225, rather, not plus. I'm going to subtract that over. Remember, I have solved for x squared. So I need to take the square root. What's the square root of 81? Yeah, so x equals 9. X equals 9. Normally you have to think about the positive and negative root here, but it is the side length, so it can only be positive. When I'm finding distance, I'm literally just plugging it in, so I would recommend knowing that formula. All right, remember when you square anything, it turns positive. So even though that's a -4, when I square it, it will be positive. This is a -2. When I square it, it will be positive. Square root of 20. I am not going to leave it that way. I need to do my factor tree, which is 2 times 2 times 5. So this will simplify to 2 square root of 5 when I do my factor tree. You can leave them as fractions if they do not reduce. But all you do is add them and divide by 2. You are just averaging the 2 points. The first way we solved was solving by factoring. So when it's already factored for you, remember you are just setting them equal to 0 and solving. When it is already factored for you, you are just finding the answers by go ahead and solving those individually. If it's not factored for you, remember it has to be equal to 0. Once it is equal to 0, Then remember, I just need the factors of the last one that add up to the middle. And then once I have that, it looks like the one above it that was factored for you. You set them equal to 0, and you solve. So solving by factoring, do what you did in chapter 10, but now you're not done. Once you factor, set them equal to 0 and solve. Solving by factoring. Solving by taking the square root. That's usually everyone's favorite. So number 35. You have to have the square by itself. Take the square root. You're not done yet. And remember, for these, it's always the positive and negative root. These must be the positive and negative root. So just a reminder, to complete the square, you take, in standard form, the b value. You put that always over 2, and then you are going to square it. Remember, it's always going to be a positive number when you square it, so this one would be 25 over 4. And then you're going to use that same process to solve by completing the square. The first thing you want to do is move that constant over so that you have n squared minus 6n equal to 4. Then you're going to do exactly the same process. You're going to complete the square taking that negative 6, dividing it by 2, and then you're going to square it. That tells you what to add to both sides. Then on the left-hand side, you're going to factor it. Now your factoring is always going to be your variable, and then whatever number it was after you cut that b in half, and that group squared. And on the right-hand side, you would have just that addition of the 4 and the 9. Now you can solve by taking the square root. The square root of both sides. On the left-hand side, you just cancel out the square. And on the right-hand side, remember, you have the positive and negative root. If this had a perfect square, we would take the square. It doesn't. So we're just going to get the variable by itself. In this case, move the 3 over. So my answer will be 3 plus or minus the square root of 13. And I am finished. So we have our quadratic formula. It has to be equal to 0. Has to be equal to 0 before we start this process. All right, so I have to move that 5 over. Negative 6 minus 5 is negative 11. Now I have my A. If you do not see a number in front of that, your A is a 1. My B is negative 8. My C is negative 11. We need to walk. So listen, I am now just plugging it in. My B is negative 8. My B is negative 8. So it was already a negative there. I'm going to say that's 8 plus or minus the square root of 8 squared minus 4 times A times C all over 2 times A. The simplifying it is where I saw the most problems, all right? So leave the first guy completely alone. Anytime you square, no matter what this is, all right, because he was technically a negative 8 squared, it is positive. All right, so negative 8 times negative 8 is positive 64. I have a negative 4 times a 1 times a negative 11. What is that? Negative 4 times 1 times positive 44. So this is going to be plus 44. All over 2 times 1 is 2. Take it one piece at a time. I promise it's not hard. All right. Then I'm going to add what's inside. So again, leave that 8 alone. 64 plus 44 is going to be what? 108 over 2. I need to do the factor tree here, just like I did all across this whole test for the last few sections here. 2 and 54. 2 and 27. 3 and 9. 3 and 3. So I'm doing that factor tree just like I've been doing. I still have the 8 right there, but now that great big radical, I take a 2 and a 3 out. So what's on the outside here? The 2 and the 3, which is a 6, and my 3 is left on the inside. And remember, the only way to reduce is every outside number can be divided by the same thing. Can every outside number be divided by something? Yes, they can all be divided by 2. So I'm going to divide this 8 by 2, this 6 by 2, and this 2 by 2. So I have a 4 plus or minus 3 square root of 3 over 1. I don't even need to put the 1 because it's a 1. Had it been any other number besides 1, I would need to put it there. Or if you just always want to put it there because you're afraid you'll forget it, you can do it like that. But your answer key will look like this.